So these are the optical components for our project. We plan on using mirrors on the bottom of each chess piece to act as a base layer for the values to differentiate each piece. And then we will use different ND filters, neutral density filters, to differentiate the values that we get from the measured light of our pieces. And we have two different sets of filters to allow us to get at least 7 different values to differentiate the pieces. And then over here we have our photodiodes we plan on using. Currently we are going through extensive testing to determine which is best for our project.
These are our illumination source, which are green LEDs. They will go into this fiber, which will be used to transfer the light from the LEDs to the bottom of each piece to measure the intensity of the reflected light. This is our illumination source. The green LED is built with a simple circuit. The light from the illumination source will be coupled with the fiber, and they would reach the end of the fiber. The light would travel at the end of the fiber and would hit the bottom of the piece, and the light would be reflected off the piece to the photodiode, which would measure the intensity of the light.
And then for the second part of the optical setup involving the photodiode will be connected to a circuit. The circuit won't be this simple. It will require a much more expensive circuit, but essentially the photodiode will measure the reflected light from the bottom of the piece, and then we will base the value to determine what piece is on top of the square, either based on current or voltage. We aren't quite sure yet how we're gonna determine that. And then this is the small little demo. Right now the photodetector is measuring ambient light, and then when you cover it, it goes away. So then it goes to ambient light. And once the fiber is illuminating and providing light, it will measure a value.
We would only use one fiber under each square though.
So here we have the RGB LEDs we're going to use. They're the common anode configuration. And then here we have 6 shift registers. So we're going to use them to power the columns for our RGB LED matrix.
Over here we have our microcontroller, the Teensy 4.1. This will be serving as the central processing unit of all of the different hardware we have for the system and connecting it all together.
And this is the display that we'll be using in the project. We'll be using it to display most of the information in the menus for the user when they're playing.
In this demo, we have the microcontroller set up just on my laptop, and it's right now just oscillating between the LEDs through the first 8 bits of this shift register. So in the program, it's right now just going through a simple for loop, and if I change the value of the delay to something larger, let's say 550, it will upload to the microcontroller. It's taking a second to flash, and now it is going much slower.
So in order to save pins on the microcontroller, we used a shift register. So each output pin on the shift register corresponds to one color of the LED. So as you can see, we're turning on the red, green, and blue, and basically that's how we will control the array.
Here we have a display test. It switches between 5 different screens showing different colors and locations of text. The way it's configured is by using this library called TFT ESPI, and through that I configured it specifically to match the pin layout of the Teensy. Here's the code itself that makes it switch. Here we have a test for the touch screen. As it's configured right now, it's right now outputting whatever I touch to the serial monitor on my computer. So if I touch just somewhere in the middle of the screen, it's going to read me a bunch of coordinates based on where that was, along with my corresponding pressure.
These are the 3 main components that we'll be using for our power system design in our senior design project. These are 18650 lithium-ion batteries with a nominal voltage of 3.7 volts and a capacity of 3000 milliamp hours. This is a voltage regulator buck converter that we'll be using to align the voltage with our needs. It has a potentiometer that allows us to choose the level of voltage that we'll be using for the output. And this is a battery management system board. It has charge balancing capabilities as well as many protection features that we'll be using to protect our batteries. Here's an example of how our battery supply will work. These batteries are connected in series, so they're providing a total of 7.4 volts to the system. We are not using the management board because it's not necessary here for such a simple demo, but the voltage goes into the buck converter, which is currently set to 3 volts, and into the LED. But if we want to adjust the voltage, we can take a screwdriver and use it on this screw in the potentiometer, and you can see we can increase or decrease the voltage to whatever levels we want. I'm gonna set it to 5 volts, which is the voltage we'll be using for the circuits in our project. And as you can see, it can maintain a voltage pretty constant, right now set to 5.04 volts.